Hi, in this video, we'll be writing and solving proportions. So you may be wondering, what's the difference between a proportion and a ratio? And so we're going to take a moment to take a step back to remind ourselves what is a ratio. So in a ratio, we compare two numbers by division. In a proportion, we have two ratios, not one ratio, but we have two ratios that are now equal to each other. So sometimes we don't know one of the values in a proportion, but just knowing that those two ratios are equal to each other can help us to solve for that unknown value. And the best way for you to see what I mean is just to see an example. So let's say, for example, that 5 over 6 is equal to x over 18. So as you notice here, we do have one number that's unknown. We have a ratio over here, and we know it's equivalent to a ratio over here. And so there are three methods that we can use to solve this proportion, to solve for that unknown value. And so the first method that we're going to use is just knowing that we have equivalent ratios and remembering that when we learned about equivalent fractions, a common number, if we multiply the numerator and the denominator by a common number, we'll get the equivalent fraction. The same is true for a proportion. So here we have, if we take a look, we actually can figure out what to multiply 6 by in order to get 18. And we know that that number is 3. If it was a little bit harder to figure out, we could do a division. We could say 18 over 6 is 3, which means when you multiply by 3, you do in fact get 18. All right. Some questions will be harder, and that's why we're going to look at more methods. All right, so now that we know we multiply the denominator by 3 to get 18, the same rule would apply for the numerator. We would have to go ahead and multiply it by 3 to get that unknown number here. And so since 5 times 3 is 15, we know that this number here has to be 15. So but we know 5 over 6 is actually equal to 15 over 18. The answer is not all this. If you're asked to solve, they only want the value of x. The value of x is 15, and that's done. All right, so that looks relatively simple enough. You're looking for that, again, you're looking for that common number that multiplies by the numerator and the denominator to get those values. But sometimes this method is not that easy, and I'll show you an example, and we'll talk about another method that we can use to solve in that particular case. Okay, so here we have another proportion, x over 12 equals 2 over 8. And we could go ahead and try to do it the way we did it before, and it would actually work. So we could go ahead and look at what you multiply 12 by in order to get 8, but that's a harder question to answer. Remember, off to the side over here, we did the division to figure it out. But in this case, because it's not super clear what we would have to multiply 12 by to get 8, or even what we would multiply 8 by to get 12, because that's not a super clear question to answer. In this case, we have other options. So here's one of the other options. We can solve the proportion algebraically using inverse operations. So remember, when you're isolating a variable, you do everything that you can in order to get that variable alone. So in this case, we see here that x is divided by 12. And because x is divided by 12, we want to do the opposite of that in order to get x alone. So we can go ahead and multiply x by 12. If you do that, that will happen. It will go away. But whatever you do on the left side, you must also do on the right side to balance our equation. So we have to multiply the right side by 12 as well. So here now we have that x over 1, or just x, is equal to 2 over 8 multiplied by 12. And remember that multiplying by 12 is the same thing as multiplying by 12 over 1. So whichever way you prefer to do this multiplication, you can, but the way I'll demonstrate it is just by multiplying the numerator by the numerator and the denominator by the denominator. So we have that x is equal to 2 times 12 in the numerator which is 24, and 8 times 1 in the denominator, which is 8. Now we can go ahead and simplify that by looking for the greatest common factor of 8 and 24, which in this case is 8, so it becomes actually much easier than it could have potentially been. We divide the numerator and the denominator by 8, and we get that x is equal to 3 over 1, which ultimately is just 3. And that's our second method that can be used to solve a proportion. There is one third method, and I left my favorite one for last, and that is called cross multiplication. So we're going to go ahead and do one more example using cross multiplication. Okay, so in this one, it would actually be really easy to use the first method. So I want you to take a second just to look at this and think about the equivalent fraction and think about what you'd multiply this by to get that, and then, because you did that first one with me. All right, now keep that answer in your mind, and let's look at this third method and see if we get the same answer. All right, so cross multiplication is kind of taking what we just did when we isolated the variable, but we're mushing the steps together and we're doing it a little bit faster. So when you cross multiply, we multiply the left top by the bottom right. So I'll write that down. We would multiply, in this case, 2 by 25. And we also multiply the bottom left by the top right to make a little butterfly here. And that is, and I'm going to put it next to it here, that's 2. Sorry, that's not 2. We already did that side. All right, that is 5 times x. And when we do those two multiplications, like magic, these two things will be equal to each other. So now we can use that fact to isolate our x. So we can go ahead and simplify the right side, and we get 50 when we multiply the left side. We get 50 when we multiply the left side is equal to 5 times x. Now we're still going ahead and isolating our variable. Right now 5 is being multiplied by x, so we have to divide so we can get rid of it. But whatever we do on one side, we have to do on the other side as well. So we have to divide the left by 5 as well, and we get that x is equal to 10. Now, is that what you thought x would be equal to when you did the first method? Hopefully it is, because that would mean that you were comfortable doing the first method. Now, it seems a little bit excessive to teach you 3 ways to do one thing. I am aware. However, all 3 ways are useful in different circumstances. So I encourage you to practice all 3 ways, get comfortable with your preference, and use your preference the most, but also call on the other options when needed. All right, have a good one.